Hello, my name is Corinne Paulson, and I am doing a lesson on what is frequency distribution and how to determine frequency distribution for a data set. Frequency distribution, what is it? It is the organization of raw data in table form. It uses classes and frequencies. But what is raw data? It is data that is collected from an observation or experiment. What is categorical frequency? It's nominal or ordinal level data, and it can be placed in categories. What is categorical frequency distribution? Here's an example. 25 Army indicates were given a blood test to determine their blood type. Here is the raw data. So we're going to construct a frequency distribution for this data. In red here is all of the possible blood types. The first thing on this table we are going to put is the class. Class is all the possible blood types. So it can be A, B, O, or AB. Now, we're going to tally up the information that we have. So, one by one, we're going to tally it up. I already have all the information, so I'm going to do the tallies really quick. Now, I'm going to have the frequency. The frequency is the same number as the tallies. Now, for the next one, I'm going to have the percent. Of each of these. So, this is 20%, 28%, 36%, and 16%. That is a categorical frequency distribution chart. What is grouped frequency distribution? Group frequency distribution are used when the range of the data is very large. The smallest and largest possible data values in a class are the lower and upper class limits. Class boundaries separate the class. To find a class boundary, average the upper class limit of one class and the lower limit of the next class. The class width can be calculated by subtracting successive lower class limits, subtracting successive upper class limits, and subtracting upper and lower class boundaries. The class midpoint can be calculated by averaging upper and lower class limits. There are 6 rules for classes in grouped frequency distributions. the first rule is that there should be 5 to 20 classes. The second rule, class width should be an odd number. The third one is the classes must be mutually exclusive. The fourth one, the classes must be continuous. The fifth one, the classes must be exhaustive. And the final one, the width of the classes must be equal. So the 6 rules are, it has to be 5 to 20 classes, the class width should be odd, they should be mutually exclusive, continuous, exhaustive, and the width must be equal. So how to construct a group frequency distribution? The first step is to determine the classes. Find the class width by dividing the range by the number of classes. So, if I were to have a set of data, which has gone missing. Okay, so if I had a set of data and the highest number is 134 and the lowest number is 100, I would subtract the 2 and have the range as 34. To find the width of that data, I would take the range, which is 34, and divide it by 7. Now remembering the rounding rule, which is always round up if there is a remainder, the number would be 5. So, if I decide to construct a group frequency using raw data, which my raw data set has gone missing, for convenience, I will choose the lowest data value, which is 100, for the lowest class limit, 100. And then the subsequent lower class limits are found by adding the width to the previous lower class limits. The first upper class limit is 1 less than the next lower class limit, and the subsequent upper class limits are found by adding the width to the previous upper class limits. So here is my chart that I'll be looking at. Up top there is class limits, class boundaries, tally, frequency, and cumulative frequency. We'll go by those one at a time. First off, I have class limits. I'm starting off with 100, which is the smallest number, and with my class limit being 5, including 100 to 104. And I go all the way down to the biggest number, 134. Notice that there are 7 classes. 1, 2, 3, 4, 5, 6, 7. That was exactly asked from the data. Now for class boundaries. With class boundaries, It's used to make sure that there are no gaps. As you can see, there's a 1-digit gap between 104 and 105. So if I happen to have a decimal in the data set, then I could have 104.1 and it would go nowhere. So the class boundary is to prevent that from happening. The best way to think about it is to the first number here is to subtract 0.5 from what we have in the beginning. So instead of 100, it would be 99.5 through here, and I would add 0.5. So 104.5. Now for the next one, I start where I ended. So 104.5 to 109.5. And I continue on. Now, much like the one that we used for the blood types, I would take that raw data, which again has gone missing, and I would tally up all of those numbers. I do have the numbers next to me. So one at a time, I would tally up the numbers that I have. The next part is frequency. Much like the previous one, the frequency is the same as the tallies. Now for cumulative frequency. Cumulative frequency is just when you add the numbers in order. So I have 2 here, and then 2 plus 8 is 10. 10 plus 18 is 28. 28 plus 13 is 41. 41 plus 7 is 48. 48 plus 1 is 49. 49 plus 1 is 50. That is the whole grouped frequency distribution chart. Thank you. That's it.